In this video, I'm going to talk about nuclear charge and nuclear attraction. Are they the same? Are they interchangeable? So let's look at nuclear charge. What does it mean by nuclear charge? Nuclear charge simply means the number of protons in the nucleus. I have a period table here. Across a period, proton number is increasing. Let's say we take period 2, from lithium to neon. Proton number is increasing from 3 to 10. So the number of protons in the nucleus is increasing across a period. So we say that nuclear charge is increasing across period 2, across period 3, across all periods. Now look at going down a group. So let's say I pick group 2, from beryllium to radium. Again, proton numbers are increasing. So we say that nuclear charge is increasing going down a group. So where can we use nuclear charge for our explanation? As an example of past year question here, explain why the first ionization energy of neon is greater than that of fluorine. Neon has a proton number of 10, fluorine has a proton number of 9. So we can see that in the nucleus of neon, there are 10 protons. In the nucleus of fluorine, there are 9 protons. So neon has greater nuclear charge in its nucleus compared to fluorine's nucleus. That is why the first ionization energy of neon is greater than that of fluorine. But they both have the same shielding. That is why the first ionization energy of neon is greater than that of fluorine. When we are comparing the atoms of two different elements, we compare their nuclear charge because two different elements, they have different proton numbers. Next, what is nuclear attraction? Nuclear attraction means the attractive forces between nucleus and electrons. Nucleus has protons in it. Protons are positively charged. Electrons are negatively charged. So these two oppositely charged species, they have electrostatic forces between them. That is nuclear attraction. There are a few factors affecting the strength of nuclear attraction. The first one will be the distance of electrons from nucleus. I will use example to explain factor number 1. Two atoms. Atom X has 2 shells. Atom Y has 3 shells. Valence electrons of atom X in shell number 2 are closer to the nucleus compared to atom Y. Atom Y, its valence electrons are in shell number 3, so they are further away from nucleus. Further away from nucleus are feeling weaker nuclear attraction from the nucleus. Factor number 2, shielding. So we use atom X and Y again. Shielding means the electrons between the valence shell and the nucleus. So atom X has shielding from shell number 1. Atom Y has 2 shells between the valence electrons and nucleus. So atom Y has more shielding compared to atom X. More shielding, weaker nuclear attraction. So the valence electrons of Y are feeling weaker nuclear attraction from the nucleus. Factor number 3, ionic charge. If magnesium loses 1 electron, it will form a positive 1 cation. Loses 2, it will become a cation with positive 2 charge. So magnesium 2 ion has higher charge on its cation. So its outer shell electrons is feeling stronger nuclear attraction from the nucleus because of the charge of the cation. The last factor that I'm going to talk about will be effective nuclear charge. Now this one we go back to atom X and Y again. Higher effective nuclear charge, stronger nuclear attraction. So what is nuclear charge? Nuclear charge is found by the following formula. The formula is effective nuclear charge equals to proton number minus the shielding electrons. So for atom X, its proton number will be 8. Shielding will be electrons in shell number 1. 2 electrons in shell number 1, so they are the shielding electrons. So the effective nuclear charge of X let's find the effective nuclear charge of Y also. So X has a higher effective nuclear charge compared to Y. Electrons of X in the outer shell is feeling a stronger nuclear attraction from the nucleus. Atom Y, its valence electrons is feeling a weaker nuclear attraction from the nucleus. We go back to the same question. Why is the first ionization energy of neon is greater than that of fluorine? Neon has 10 protons, fluorine has 9. They have the same shielding. The electronic configuration of neon will be 1s2, 2s2, 2p6. For fluorine will be 1s2, 2s2, 2p5. First ionization will be removing the outermost electrons. For neon, we'll be removing this 2p6 electron. So this valence electrons of neon is experiencing shielding from shell number 1 and number 2. So the shielding is 4. So the effective nuclear charge of neon is 10 minus 4 equals to 6. Let's do the same for fluorine. First ionization of fluorine will be removing electrons from 2p. So this valence electrons of fluorine is also experiencing shielding from the 2 inner shell 1s2, 2s2. So shielding is also 2 plus 2, which is 4. Effective nuclear charge will be 9 minus 4, which is 5. So let's look at the answers again. Greater nuclear charge of neon compared to fluorine. Same shielding. If this is a 3 marks question, so the third point will be greater nuclear attraction for electrons in neon, because the strength of nuclear attraction depends on the effective nuclear charge, and neon has higher effective nuclear charge compared to fluorine. We look at another question that is using nuclear attraction in its explanation. The question is, explain why there is an increase in the successive ionization energies of fluorine. Fluorine has 9 protons, hence 9 electrons. Its electronic configuration is 1s2, 2s2, 2p5. Valence electrons in subshell 2p. Successive ionization means removing the electrons one by one from the same atom. So first ionization of fluorine will be removing 1 electrons from the fluorine atom to form a positive 1 cation. Second ionization will be removing 1 electron from the positive 1 fluorine cation to form a positive 2 cation. So if we just do it continuously, successively, at the end, we will be able to remove all 9 electrons from fluorine. So in the successive ionization, we can see that the cation charge on fluorine is increasing from positive 1 to positive 2, positive 3, until positive 8 and 9. So because of the increasing cation charge, Like what we have seen in factor number 3, ionic charge. Higher the cation charge, there's an increase in the nuclear attraction between the electrons and the nucleus. So go back to the main question of this discussion. Are nuclear charge and nuclear attraction the same? So the conclusion is nuclear charge and nuclear attraction, they are different and they are not interchangeable.